Recording. All right, so quick reminders. If I forget reminders, you can bring that up. So we're aiming for the test tomorrow. Okay, so you've already seen one test. Oh, one other thing I was going to mention. It looked like for a lot of you, when you were trying to send your homework, it wouldn't all fit in one email, or your homework was too big. There was no problem for the exam because the exam was only, what, 1 or 2 pages, something like that. But some of your homework was like 20 pages, and it would not fit on one file, or one email could not send that. So you can break it down into 2, or if you want to do something like one email per section, I suppose, or however you want to do it, that's fine. But just watch out for that. Some of you tried to send the whole thing at once, it wouldn't work. Watch out for sending in some strange formats, because if you have some weird format, maybe I can't open it. But most everybody, it was okay last time. So, but just to remind you, you might not be able to fit it all in one. Okay, and so what do you turn in? You turn in all of this. If you want to turn in early, that's fine. We're skipping 2.4 altogether. Okay, so again, the game plan is a little bit after 12. I will either email you or send through Canvas announcements, most likely Canvas announcements. And I'll email you the test, but I'll also project it like I'm projecting here right at 12:10-ish in case that's better for you. If you want to print it out, you may. Okay, and so as usual, mute yourselves. I don't want to hear any background noise, but have your actual camera on, so nobody, you're hiding your camera or anything like that. And what else? You have to have your actual background. So background should not be, outer space, Golden Gate Bridge, or anything like that, please. Okay, and let's see, what else? And then Prasanna and I are just going to look around and see whose camera is not on, who looks like they're talking to somebody, or who looks like they're furiously texting somebody and stuff like that, right? So you're not supposed to do that. Okay, I won't call the row. Now, I'll see that you're actually there, so you won't hear me call your name. I don't have to. I'll just look. I got the whole hour to check who actually shows up, right? So if I get a test from you, but you weren't there, guess what? You're getting a 0. It doesn't count. You weren't actually at the test, right? And then once it's 1 o'clock, we'll close as usual. So I'll close the session, and then you have until 1:05 to submit your test. So again, just get your cell phone and click, 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 or you can, you can scan it, like a cam scanner or something like that. And then I'll give you until 1:30 to turn in the homework. But again, if you want to turn in the homework early, that's perfectly fine. Okay, so other than that, I guess we'll go ahead and get started now. And I'm aiming mostly for quantity rather than quality. I want to make sure that you get it all. And yeah, you can have your cheat sheet. And some of you are asking, no, you don't have to submit your cheat sheet. So you can have your cheat sheet, but you don't have to turn it in. But besides the cheat sheet, you can't use any other books or notes or computers or people, obviously. So that's not allowed. Okay, and then I reserve the right to not necessarily do some of the problems if I think it's either too trivial or it takes too long, or I don't feel it's worth it. Okay, so with that background, 2.5, number 7. Number 7, removable discontinuity at 3, jump discontinuity at 5. So removable means you can plug up the hole. Jump discontinuity at 5. Okay. 5. This is 2.5, number 7. All right, so removable discontinuity. So something like this. Okay, but at 5, you have a jump discontinuity. So you jump either up or down, and then maybe something like that. Okay, so this is a removable discontinuity. I can just plug up the hole. Here, there's no way to plug up the hole with just a single point. Okay, so that's pretty much about it. Okay, same section, number 8. So neither left nor right continuous at -2. Continuous only from the left at 2. Okay, so neither left nor right continuous at -2. All right. So we'll do something like this. Okay, -2, neither left nor right continuous. So something like that, and maybe a dot here. Continuous from the left at 2, though. So I can actually reach the function coming from the left at 2, and then it jumps off and does something like that, I suppose. Okay. And let's see. Same section, number 19. So this is all 2.5, it looks like. Why is the function discontinuous at a certain point? So 19 is a piecewise defined function. So it says x plus 3, x is less than or equal to -1, and 2 to the x is greater than -1, and then we're at a equals -1, which is the only place that you'd have to worry about it. Okay, so the limit as x approaches -1 from the left. Okay, so if I approach -1 from the left, less than or equal to -1, I'm coming this way. So -1 plus 3, which is 2. But the limit as x approaches -1 coming from the right. So that means I have to use this function, 2 to the -1, which is 1/2. Okay, so that means the limit as x approaches -1 of the function does not exist. Limit as x approaches -1 of f of x does not exist. So f is not continuous. F is not continuous. A equals -1 because the two-sided limit doesn't exist there. Okay. All right, now let's see. Not sure what happened with the chat. I might have lost some. Seems like I lost part of it. Okay, here we go. I think. (31), same section. Square root of 1 plus 1 over x. Just ask for the domain. Okay, so for the domain, I need this stuff to be greater than or equal to 0. 1 plus 1 over x is greater than or equal to 0. Multiplied by x over x, get my common denominator. So x plus 1 over x is greater than or equal to 0. Okay, so my boundary numbers are whatever makes the top 0, whatever makes the bottom 0. So what makes the top 0? -1. What makes the bottom 0 is 0. Okay, so okay, if I plug in -1, I get 0 greater than or equal to 0. That's true. Plug in 0, that's a no-no. I'm not allowed to divide by 0. So closed here, open here. Region 1, region 2, region 3. 1, 2, 3. Region 1 would be a number like -2. Region 2 is -0.5. Region 3 is 1. Fraction bar, fraction bar, fraction bar. Okay, -2 plus 1 is negative. -2 is negative. Negative divided by negative is positive. Is a positive greater than or equal to 0? That's true. Here in region 1. -0.5 plus 1, that's positive. -0.5 is negative. Positive divided by negative is negative. Is a negative greater than or equal to 0? That's false. Do not shade in region 2. Region 3, plug in 1. 1 plus 1 is positive. 1 is positive. Positive divided by positive is positive. Is a positive greater than or equal to 0? That's true. All right, so the domain is -∞ to -1 bracket, union parenthesis, 0 to infinity. I'm including -1 bracket, not including 0, and negative infinity and positive infinity. Okay. All right. So that's that. I'll hold it there for a moment. Meantime, 2.3, number 19. Okay, 2.319. Whoops. That's kind of funny. 2.319, limit as x approaches -2. X plus 2 over x cubed plus 8. Okay, this one you have to remember the rule for the sum of cubes. There's a sum of cubes formula. Okay, so quick timeout. A cubed plus b cubed, a plus b, a squared, b squared. The middle was an ab. This one's a plus. This one's the opposite of that, so that's a minus. Okay, so here's the formula for the sum of cubes. If you want a difference of cubes, minus, minus, plus. If you want to put it on your cheat sheet, you may. Okay, so this is the limit as x approaches 2 of x plus 2 over x plus 2, x squared minus a times b is 2 times x, plus 2 squared, which is 4. Okay, and then these guys cancel out, leaving me with a 1. My chat box got too big all of a sudden for some reason. All right, so limit x approaches 2 of 1 over x squared minus 2x plus 4. Now you just plug in. So it's 1 over 2 squared is 4, minus 2 times 2 is 4, plus 4. So that comes out to be 1/4, it looks like. So 1/4. Okay, 2.553. Intermediate value theorem, looks like. X to the 4th plus x minus 3 equals 0. Okay, so the function is continuous. F, it doesn't say f, but I'm calling it f is continuous because it's a polynomial. And then they give you between 1 and 2. All right, so f of 1 is 1 to the 4th plus 1 minus 3. That comes out to be -1. F of 2, 2 to the 4th plus 2 minus 3, which is 15. Okay, so one side is positive, one side is negative. So by the intermediate value theorem, there is a C somewhere between 1 and 2. I'm going to open it up from 1 and 2, such that f of c is equal to 0. Okay, so one side positive, one side negative. It's a continuous function, so somewhere the function value is 0. That's what they call c. Okay. All right, 2.237 I see in the chat. Yeah, we talked about that limit. X approaches pi over 2 from the left. One over x equals x. Okay, now since I talked about it earlier, I don't think I want to go through all of that unless there's nothing else left in the chat. Okay, so look back in your notes. I think we did this. The key thing also is to get pi over 2. 1.57 something. See if I can get that quickly on my calculator. Pi divided by 2. 1.57076. Okay, so if you're going to come from the left side, then in your table, we'll do 1.5, 1.57, 1.5706. Oh, I'm sorry, 1.5707, 1.57079, and so on. Okay, I take it back. Maybe I didn't do this one. But at the same time, maybe I'll just do the last one. 1 divided by parentheses 1.57079 times cosine of 1.57079. Okay, looks like it's going to infinity. Unless I type something in wrong. But yeah, you should see these numbers get bigger and bigger and bigger. Okay, so that's all. Okay, let's see. 2.237, 2.1, number 5. Number 5. Y is equal to 40t minus 16t squared. Okay, to save time, I'm only going to do the last one, which is the 4, so t equals 2, lasting for 0.01 seconds. Okay. That means it's 2 comma something and 2.01 comma something. Okay. So plug in 2, 16, plug in 2.01, 40 times 2.01 minus 16 times 2.01 squared, 15.7584. So average velocity, slope, so 15.7584 minus 16, y2 minus y1, divided by x2 minus x1. Okay, so these are feet, I believe. Was it feet or meters? Feet. This is seconds. This is feet. This is seconds. So if you divide, you're doing feet per second, which is what we want. Okay. 4. Okay. So what does that come out to be? Negative 24.16 feet per second. So part B, estimate the instantaneous velocity. I'd say negative 24. Negative 24 feet per second. Seems to be very close to that. 2.329. 2.329. Limit as t approaches 0. 1 over t radical 1 plus t minus 1 over t. Notice you can't plug in directly. Okay, so common denominator, radical 1 plus t, radical 1 plus t. Limit t approaches 0. 1 minus radical 1 plus t over t radical 1 plus t. So it looks like I do that conjugate business again. So the conjugate 1 plus radical 1 plus t, 1 plus radical 1 plus t. So that way this looks like a minus b, a plus b, which is a squared minus b squared. Limit t approaches 0. So 1 minus parentheses 1 plus t all over. Don't multiply at the bottom, just leave it. T radical 1 plus t, and then parentheses 1 plus radical 1 plus t. Okay, then you notice the top can be written as 1 minus 1 minus t. These cancel out. That t will cancel this t, leaving me with just a negative 1 on top. So limit t approaches 0. Please notice, keep writing lim, lim, lim. I'll look for that during the test. You have to keep writing limit t approaches 0. That's proper. Negative 1 over radical 1 plus t, 1 plus radical 1 plus t. Now you can plug in 0. Once I plug in 0 here and here, you don't have to write lim anymore. So negative 1 over radical 1, which is 1. 1 plus radical 1, that's 1 plus 1 is 2. So final answer looks like it's negative a half. Okay. 2.353. Okay. Not sure I have time to go over 2.353. We did do it before. Okay, so I'll only do that if I have time at the end. Sorry about that, but we did that. So look back in your notes or the previous videos. We did cover that one. Let's see. 2.1, number 7. Okay, so I'll only do one of these perhaps. They're all the same. So how about I'll do 4, from 4 to 6. 2.1, number 7. So what should I write down? So I'm doing 4, so from 4 to 6, it's 4 comma 79.2 and 6 comma 176.7. Okay, so you might not be able to see it now, but I'll get a 4 comma 79.2, 6 comma 176.7. So I'm only doing number 4. Okay, so it's just a slope for the average rate of change. So 176.7 minus 79.2 over 6 minus 4, which is something divided by 2. 176.7 minus 79.2, 97.5 divided by 2, 48.75. And just give the units, which are going to be feet per second. Okay. All right, let's see, 2.3. And 2.319, I already did. 2.665. 2.665. Okay, I have done it before, but I'll do it. It's squeeze Theorem 1. Find the limit as x approaches 0. sine x over x. Okay, Dorina, what is the word before at and a equals -1? I'm not sure what you mean by that. Maybe Prasanna's got that. You can check with me about that later. Okay, so this one, you start off with sine x between -1 and 1. That's true for any sine function. Okay, then you divide by x, divide by x, divide by x. Okay, that will stay like this when x is greater than or equal to 0. Oh, sorry, that should be infinity. My bad. Yeah, and now limit as x approaches infinity of -1 over x is 0. And the limit as x approaches infinity of 1 over x is 0. Okay, so you have this relation, smallest function, biggest function in between. The two extremes both go to 0. The squeeze theorem says anything in between has to go to 0. So by squeeze theorem, the in-between function, limit as x approaches infinity, sine x over x also equals 0. Okay. Let's see, 2.2, number 21. .221. Well, that involves just punching in stuff, so I don't know if I want to do all that. But I believe you had a quiz question that was very similar to that. Okay, so maybe I'll just do the two extremes. -0.0001 and positive 0.0001. Okay, so I'm going to do that perhaps. So parentheses e to the 0.000 minus 1 divided by -0.0001. 4.99875. And then positive 1. 5.00125. Okay, so it looks like the limit is 5. 4.999, 5.001. This one here. Okay. See, 2.743. 2.743. 82 minus 16 squared. Velocity and the speed when t equals 4. Okay. F prime, limit h approaches 0. 80 times t plus h minus 6 times t plus h squared minus parentheses 80t all over h. Limit h approaches 0. So let's see, 80t plus 80h minus 6 times parentheses t squared plus 2th plus h squared minus 80t plus 6t squared all over h limit h approaches 0, 80t plus 80h minus 6t squared minus 12th minus 6h squared minus 80t plus 6t squared all over h. Cancel, 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 cancel. 1, 2, 3 terms that all have an h. Factor out to h. It'll cancel the h on the bottom. So 80 minus 12t minus 6h. Cancel, cancel. Limit h approaches 0. 80 minus 12t minus 6h. Now you plug in 0 for h. That's gone. So 80 minus 12t. For those of you who know the shortcut, double check. Yeah, that works. Okay, then they just tell you to plug in 4. So f prime of 4 is 80 minus 12 times 4, which is what? 80 minus 48. 32 meters per second. Okay, that's also the speed. So that's velocity and speed both. Okay. All right, let's see. Okay, Prasanna, I'm assuming you got that. Okay, Darina, I'm still not sure what your question is asking. If you want to give it back. 2.237. What time is it? Yeah, we talked about that one already. 2.7, number 5. 2.7, number 5. 4x to -4. In case you're wondering, yeah, I'll keep working, but I'll blab. In case you're thinking you're trying to strategy, oh, let's just get all the questions that he didn't do yet. I'm aware of that. I know that might be happening. If all of you decided out there, oh, he covered all these problems, but he didn't show you this, so now I'm just going to, all of you as a class are going to put down all the rest. I'm aware of that. I know that might be happening, and I don't mind that. So again, there's really no reason why you can't come up with a 70% homework rule, since I end up doing it. And on the day before the test, some of you guys are maybe making me do all the rest of the problem. I'm aware of that. I want to make sure you all have it. But obviously, if you just satisfy the homework requirement, but you don't know what's going on, that isn't going to help, right? So you want to make sure you know how to do all these problems a little bit later. So if it looks like I'm doing all the rest of the problems, I'm aware of that. If you're trying to trick me into doing that, that's okay. I don't mind. Okay, so y prime, okay, that's another symbol for derivative. Limit h approaches 0. F of x plus h, 4 times x plus h, minus 3 times x plus h squared. That's f of x plus h, minus the original function, 4x minus 3x squared, all over h. Limit h approaches 0. 4x plus 4h minus 3 parentheses, x plus h squared, x squared plus 2xh plus h squared, minus 4x plus 3x squared, all over h. I've reached the bottom of the paper, so I got to go up. So this is going to be what? Minus 3x squared minus 6xh minus 3h squared, and the rest is just a copy. Okay, so coming up now. Limit h approaches 0. 4x plus 4h minus 3x squared minus 6xh minus 3h squared minus 4x plus 3x squared all over h. And now what can we cancel out? gone, 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 gone. 1, 2, 3 terms. And big surprise, they all have an H. That's the way these problems always work out. In fact, we know the way the game works. It's going to be like that, right? Might as well just do it right away. And what do I have left? 4 minus 6x minus 3h. Limit h approaches 0. 4 minus 6x minus 3h. Now plug in h equals 0, so that's gone. So final answer, 4 minus 6x. Okay. Those of you who know the shortcut, yes, that's correct. Okay. You say, I don't know the shortcut. Don't worry, the next chapter is all shortcuts. And you're at the point 2, negative 4. So the slope of the tangent line is 4 minus 6 times 2. You plug in for x. How come you don't plug in negative 4? That's for y. So you plug that in. So 4 minus 12, negative 8. So point slope form, y minus a minus 4 equals m times x minus 2. You may stop right there. That's the equation of the tangent line. Okay. And let's see, 2.829, 2.729. Okay, 2.829, I'm pretty sure I did that one. It's a little bit long right now, so I'm going to have to not do that one. Look back in your notes for that one, though. 2.729, let's see if I've done that before. 2.729. Okay, same thing. I think I did 2.729, so it's going to take me too long to do that. So I'm sorry, I'll have to hold off on that. 2.6, 2.616. 2.616 was not assigned, so I'd rather not do that one. 2.5. 2.553, okay, I already did that one. 2.1, number 3. Number 3. Okay, so we got all these numbers. I obviously can't do them all. Maybe I'm willing to just do one of them. How about I'll do number 4, 1.999. So 2.1, number 3. We have y equals 1 over 1 minus x. Okay, so they give me the point 2, negative 1. And the only one I feel like doing is 1.999. 1.999 comma something. Okay, so what happens when I plug in 1.999? I get 1.001 repeating. Oops, this is repeating. All right, so the slope is negative 1.001 repeating, y2 minus y1 divided by x2 minus x1. .001 repeating. That's very close to 1, so our guess is that the slope of the tangent line is 1. Okay, the equation of the tangent line, point slope, y minus a negative 1 equals m times x minus x1. Okay, that's that. 2.625. $2.625. And there's X plus 4. X plus 3x squared over 4x minus 1. Okay, because this is a square root, this is almost like first degree, just like this. So I'll divide top and bottom by x in a special way. Okay. Dividing by x squared underneath the radical is the same as dividing by x. Limit x goes to infinity. Okay, so that will be 1 over x plus 3 divided by 4 minus 1 over x. Now when x gets super big, this becomes 0, this becomes 0. And we have radical 3 over 4. Okay. And it's that. Okay, Prasanna got that. 2.7, number 5. Time is it? Oh, 5 minutes left. Okay, 2.7, number 5, I already did that. Okay. All right. And let's see, Prasanna says there's going to be a Zoom meeting from 10 to 11. If anybody wants to be with Prasanna for a review session. Thank you, Prasanna. Will there be 2 questions from each section like last time? Well, not sure that'll work this time. 1, 2, 3, 4, 5, 6, 7 sections. So guaranteed 1, and then some other sections have 2. Okay, Andrea, you're good. All right. I think I'm caught up. Okay, I think I'm caught up. Now, I only have about 5 minutes left. So some of you were asking for some super long limits. We don't have time for that, unfortunately, but I did go over it before. So look back at the previous notes or the previous videos for that. Okay, so anybody else with anything, please? Okay, so that'll do it. It looks like we're going to stop the share. Okay, check the chat. I don't think there was anything else in the chat. All right, so you can go to Prasanna's review session. I still have office hours tomorrow. All right, so that was good, folks. So you know what's happening tomorrow. I will email or send via Canvas announcements the test, maybe 12:01, 12:02, or something like that. And I'll also project on the screen. Again, have your video camera on, your natural background, no special background. And then I'll close the class at 1 o'clock. Then you have to turn in the test by 1:05, homework by 1:30. Okay. All right. That'll do it for today, folks. So we'll see you all tomorrow. Have a good day. And we'll see you for the test. If you want to turn in your homework early, you may turn in your homework early. That's okay, too. All right. That's about it, folks. So have a good day. See you all tomorrow for the test. Thank you.